If you're watching this video, then you successfully survived the first week of distance learning. Today we're going to start looking at complex fractions. Just a side note, there is no video for problem set 75 because it is a geometry lesson. So please refer to grade sheet. I've already written on there which problems that you do not have to do that you can skip as geo. On the board I have already written your assignments. You can see it is problem set 76. The geometry problems are going to be 11, 16, and 18, so you do not have to do those. Okay, complex fractions. A complex fraction is a fraction on top of another fraction. If you look, it kind of looks odd, and so we don't want to write fractions in that manner because it can be confusing. So if we remember that this right here means division, so this actually reads 3/5 divided by 2/3. So we're going to write it that way so it's less confusing. So we're going to take the numerator, which is 3/5, and we're going to write it side by side as divided by 2/3. Now you can see that the denominator belongs to the right, which we know the rule states that when you're dividing by a fraction, you have to flip and multiply. So we're going to rewrite it as 3/5 times 3/2. And now we have a problem in which is fairly easy to solve. We look for cross multiplication. Nothing does reduce, so then we say 9/10. The answer is 9/10. Looking at the next example, it's the same thing. The only difference is this is a fraction on top of a whole number. So it doesn't look like a complex fraction, but remember that all whole numbers can be written by writing a 1. So now I have created a complex fraction. And we'll do the same thing we did here. We'll write it horizontally so that we can avoid dividing by a fraction. So we're going to rewrite it, and since I'm not going to have room here, I'm just going to go down here, and I'm going to take this, I'm going to make it into a improper fraction, so 25 times 3, 75 plus 2, 77/3. Okay? And then I'm going to rewrite it. I'm going to say 77/3 divided by 100/1. Okay? And just like I did here, I'm going to flip the second fraction and multiply. So we're going to say 77/3 times 1/100. Be careful not to flip the numerator because we never ever flip the first part of the fraction, the dividend. We always flip the divisor. So please make sure that you do that. Again, you look for things that reduce. There's nothing that does. So you multiply 77 times 1 and 3 times 100, and you come up with 77/300. Example number 3 in your book says 15/7 1/3. Now notice I did not write it down here, but the only difference is 15/7 1/3, 15 is not a fraction, just like 100 was not a fraction. So you'll need to put 15/1 and then make sure that you make the 7 1/3 improper, and then write that horizontally as well. You can follow along for the example to see how that's done. What I did want to do is I wanted to point out example number 4 because this presents a unique situation. At first glance, it doesn't even look like this is a fraction at all because it's not complex. It doesn't have another fraction underneath it. But if we want to investigate this further, we can see that actually the percent implies something, doesn't it? The percent implies 100. So if we write this 83 1/3%, we're going to write it this way. 83 1/3 over 100%. Okay? As you do that, you're going to see that that in fact is a complex fraction. So then you're going to take the 83 1/3 and you're going to make it a mixed number. Now I'm not sure what that is, so I'm going to I meant to say it is a mixed number, make it improper. So I'm going to multiply on the side. I'm going to get 9, 24, 20. 241 plus the 1 is 250. Okay? So I'm going to get 250/3. So please make sure that you put it over 3 because a common mistake is to get 250, 83 times 3, get 250 and put it over 100. But this is the denominator. Your denominator is actually the 3. So you got 250/3, and this says divided by 100. So we write it next to it like this. Okay? And just like we did over here, we're going to flip and multiply. So we're going to say equals 250 over 3 times 1 over 100. And this time we can reduce by 25. 25 divided by itself is 1, and then there's a 0 left. And then 25 goes into 100 4 times. We notice that the 10 and 4 can still be reduced by 2, so we'll put a 5 and a 2. Okay? And now I'm kind of running out of room here, but this is going to be 5 times 1 equals 5, and 3 times 2 equals 6. So your solution is 5 over 6. So in fact, you can see that a percent can be written as a fraction, a complex fraction, and then solved by taking and dividing by 100. And isn't that what we usually do? Don't we typically take it? Now, on a side note, so I wanted to point out something here. Normally, when you write 83 1/3% as a decimal, this is what I have shown you guys up until this point, and I told you that there would be a time when I would teach you the right way to do this. But recall over here where I said 83 1/3% can be written over 100, and then you're dividing by 100. Remember that in order to make this a decimal, because it is a decimal, I've told you guys make this 1/3 as 0.3%. And you guys have been having a really difficult time making percents, repeating decimals into decimals, because you have to go 1, 2, and this becomes 0.833 with the bar. Okay? Now you can see why that is working. This 5, 6 is very close to 0.833. It's not exact, and the reason it's not exact is because this repeats itself and we moved it twice. The right way to solve complex fractions, which this is to actually put it over 100 and then flip and multiply, and when you reduce, you can see the exact answer. Okay? So recap very quickly. Complex fractions are fractions on top of fractions. We want to write them by starting by writing the numerator, and then horizontally writing its denominator, and then flipping and multiplying. Whenever you have a complex fraction with a denominator that does not have, it is not a fraction, then we simply put 1, and then we write it horizontally like we did over here, and we flip and multiply. Okay guys, if you have any questions, let me know.